So in this video, we're going to be talking about const. Const is a modifier that you can attach to local variable definitions as well as local field definitions. And so let's go ahead and fire up a new project and see what sort of stuff it allows us to do. So basically, in certain cases inside of a method, you might find yourself computing some sort of constant value. Maybe inside of a loop, you do like 10 times 20 or something like that, or you want to give a name to a particular value. Like let's say in the context of this main method, we want to give a name to the value 5.56 or something. So we could do const float name equals 5.56 f. And now what this does is we're basically associating this value with this name during compilation. And that's a very important thing about the const modifier is it only is valid during compilation, and you can only put stuff in the initializer that is valid during compilation. Not only that, there's no way to set a constant value after it has been set inside of its definition, and this constant value does not exist in the compiled program. Instead, the C# compiler will simply say, like in the case of write-line name, when it gets compiled, it just gets turned literally into this. So what's interesting is with const values, you can only have a constant value of the type of all the basic types of the C# language, such as, int, float, bool, char, decimal, byte, all that stuff, are the only types that you can have in a constant, in addition to custom-defined enumerations or existing enumerations and reference types. But the reference types thing is actually kind of interesting, and if I can go ahead and outline a little just interesting facet of constness that I find amusing.
Mm-hmm.
So basically, this is invalid because I'm not providing an initializer. But if I were to provide an initializer that just instantiates to a new class, this does not work. And the reason is this constant initializer must be a compile time constant. The C# compiler cannot actually go out and execute the code required to create this class and stick it in my object in any way. Nor is this code like a quotation in a functional language where or a define in C or C++. It must be a constant value, and that compile time type of that value must be of the same type of your variable that you're assigning it to. Which means that the only constant reference type that you can ever have is always going to be null, because null is the only constant expression that you can assign properly to a reference type. So I just find it amusing that they even allowed reference types to be constant in the first place. I don't know. I don't understand. But in addition, the last thing about local constantness that you have to be aware of is you cannot use implicit typing. Yeah, you just can't.
Okay.
Then finally, the other type, when I said the basic types are allowed, and then I said that reference types can only be assigned to null, there is actually, I didn't lie at all, but I did omit an important exception to it.
So there's kind of a caveat to all this.
And that is string. Strings will work if you assign them to that. If you assign them to a string literal. Now, I could do this and it'll fail.
Okay.
Because I can't assign it to a, well, actually, I just don't, there we go. I can do that and it'll fail because it's not a compile time constant. But if I were to do this, because this is a compile time constant, this is allowed. So string is the only reference type that you can assign because it does have a corresponding compile time constant associated with it.
Okay.
So as far as constants as fields go, they're pretty straightforward. You can give them an accessor. You must include the const modifier.
Mm-hmm.
You can give them a type, you can give them a name, and you can give them a value.
It does make a lot more sense to use pi as a constant here. I know you were using that as the read-only example earlier.
Yeah, pi is a better constant, to be honest.
Yeah.
But what's going on here, though, is this is you can think of this as a public static field that cannot be changed, although that isn't technically correct. That's basically what's going on here.
How is that not technically correct?
It's not technically correct because the C# compiler will actually take this value and stick it wherever pi is used.
Okay.
As opposed to if it was a field, it wouldn't stick the value where it's used. It would stick a reference to the field where it's used.
Right.
Which does have different meaning, especially once you talk about class libraries and recompilation. So basically, like I said, you can think of this like a static field because you can access it like a static field. So I can go myClass.pi and it's accessible from there. You cannot. It's in no way related to an instance member of my class. Again, it's just a member of my class as static. Also, just a quick note: you cannot actually do this. The static would be redundant anyway, but yeah. They just disallowed the syntax entirely to keep things a lot cleaner because, again, all constants are going to be using the static sort of methods of access.
Okay.
So really, that's about it as far as constants go. They're not a whole lot interesting, but they do, they do some useful things, and primarily when used in especially as local variables, they really do provide a way to associate a number with a name in the case that you're using that number repeatedly. So it could really go a lot towards making your code more readable. As far as using them in a class, I would generally recommend using it read-only instead, and you can go to the read-only video to find out exactly why.
Okay. All right. Well, that will wrap things up for this video. Thank you very much.